This cat puzzle is one of those games I've been playing almost every day, and if you're wondering why, it's because it's much more than just a puzzle. Hi everyone, I'm Elle, and this is Analyza, where we learn management together. You must ask that why I like this puzzle and what's its relationship to project management. Let's see how we can find all the cats. The rules are simple. There is only one cat of each color, only one cat in each row and column, and cats cannot touch each other. The first step is to look at how the colors are distributed. Since each color contains exactly one cat, we want to identify the colors with the fewest possible locations. In this example, pinks appear in only 4 squares, all located in the center of the board, covering 2 rows and 2 columns. At first glance, before considering the other constraints, each of those 4 pink squares appears equally likely, giving an initial probability of 1 in 4, or 25%. However, if you look more carefully, those same rows and columns also contains other colors, such as light blue, mustard yellow, dark pink, purple, brown, and light green. Because pink is limited to only 4 squares, it gives us good starting point. We also need to be careful that we are allowed to make only 3 mistakes. So let's look at other options. In the second row, we have yellow, light blue, and purple. In the third row, this is only one yellow square. This creates 2 possibilities. If the cat is not in the yellow square, then the second row yellow must contain the cat, since each color has exactly one cat. Let's test the first possibility. So we find that cat is indeed in the single yellow square in the third row. We can now eliminate the third row, the fourth column, all surrounding the square, and every other yellow square. After removing those possibilities, we notice that the fifth row contains only one remaining dark blue. Therefore, the second cat must be there. Now we use the rule that cats cannot touch. If the brown cat were in the possible brown square, it would eliminate every surrounding blue square. Testing the possibilities shows that only one brown location works, which also allows us to identify the correct blue square. Once the blue cat is confirmed, we can eliminate the remaining pink possibilities, which ends up only with one pink square, and the pink cat must be there. Again, we eliminate its row column surrounding a square and the other pink square. Looking at the remaining board, we see that the only possible mustard yellow square is here, so the mustard yellow cat must be there. Next, the dark pink color has only one remaining square, so we place the dark pink cat there and eliminate all affected squares. At this point, the first row contains only blue and purple possibilities. Since the blue and purple cats must occupy the remaining spaces in the first and second rows, we can eliminate the remaining blue square near the bottom of the board. That leaves only one possible dark green square, so we place the dark green cat there and eliminate the remaining dark green squares, along with the corresponding row and column. Now we're left with 2 light green square, 1 blue square, and 1 purple square. Looking at the third column, we see there's only one possible square where a cat can be placed, so we place it there. This allows us to eliminate the remaining blue squares. Finally, in the last column, only one light green square remains. That leaves one remaining purple square. Completing the puzzle, we have now found a recap. Imagine that cats represent tasks, while the color square represent different situations or possible ways to complete those tasks. Just as we use logic and probability to locate the cat, we can use the same thinking to prioritize work. Instead of choosing tasks randomly, we examine the available information, identify the options with the highest probability of success, and remove unnecessary possibilities. Some tasks naturally eliminate blockers for other tasks. In the puzzle, finding one cat often reveals the location of another. Likewise, completing one task may remove dependencies or obstacles that make several other tasks easier to complete. Sometimes the best strategy is to remove impediment before starting difficult tasks. Other times, it's worth making a small, low-risk experiment to gather information and reduce uncertainty. The key lesson is that effective prioritization is not just about selecting the next task. It's about understanding dependencies, reducing uncertainty, eliminating constraints, and choosing the sequence of work that unlocks the greatest progress for the entire project. Whether you're solving a puzzle or managing a project, the goal isn't to make the most moves, it's to make the smartest ones. Every piece of information can reduce uncertainty and help you make a better decision.